The de Broglie wavelength of a proton is 160 picometers. The kinetic energy of this proton is doubled. What is the de Broglie wavelength of the proton now? Okay, so we want some kind of relationship between de Broglie wavelength and kinetic energy. So if we think of the equation for de Broglie wavelength, lambda is equal to h over p, and then the kinetic energy equation, a half mv squared. Actually, in this case, I think a more useful form of the equation would be p squared over 2m. This is an alternative form for the kinetic energy equation, one that I'd recommend memorizing. The reason it's useful is because it's not a function of velocity, it's one of momentum instead. Mass is usually a constant. And in this case, that's useful because we have momentum in our de Broglie wavelength equation. So we can link these two equations together through P. Where does this come from if you're not sure? Well, if you consider momentum is equal to mv, rearrange that for v. Consider kinetic energy, half mv squared, and replace the v with p over m. So I've just replaced this v here with p over m, squared it. That then becomes m p squared over 2m squared, and when you simplify this by cancelling out a factor of m, you end up with this over here. So we have these two equations. We can then rearrange the de Broglie wavelength equation for momentum and then sub that into the kinetic energy equation. So kinetic energy then becomes h squared over lambda squared all over 2m, which is the same thing as h squared over 2m lambda squared. So we can see from that the kinetic energy is proportional to 1 over lambda squared. H squared, 2 and m, they're all constants. E is proportional to 1 over lambda squared. So then if the kinetic energy is doubling, and we're trying to find out the de Broglie wavelength, let's rearrange this for de Broglie wavelength. So lambda squared is proportional to 1 over E, and that means that lambda is proportional to 1 over root E. Okay, so how can we use this? If the kinetic energy has doubled, that means that E here is doubling, and if lambda is proportional to 1 over root E, then whatever factor E changes by, lambda will change by 1 over the root of that factor. So just changing the E into the factor by which it changes, changing the proportionality into a multiplication sign. This form of the expression is the same as what we have over here. Lambda gets multiplied by 1 over root 2. It was 160 to begin with, so if I times 160 by 1 over root 2, I get 113, and that is option B.